to you again what this mean. Basically, what it means is when a process is being brought into, in order for it to be processed, which is inside the running state here, okay. Okay, so it goes inside the from new is inside your hard disk. The process is new, is inside your hard disk, and it goes inside the ready state. Ready is in your RAM, your memory, and the running is inside your CPU processor. Okay, so any process which needs to be run by the processor needs to be inside the memory. Where is the new state? The new state is the whereby the process is inside your hard disk. Okay, so it's admitted inside the memory. Next, it is brought into the running state using a scheduler dispatch. A scheduler dispatch is a type of not hardware but a written program which brings in the processors from the memory into the processor here, the CPU here. Okay, each process will have a given time for it to be processed. Once the process is completed, then it will be terminated. If the process is not completed, but there is another process which needs to come in, then the process will be interrupted, will be stopped for a while, and will be brought into the ready state once again. For example, if the process needs to it needs to wait for some input output, then it will go inside the waiting state, which is also inside the memory. Once its input output has been completed, it goes back inside the memory, which is also here, and then it will be dispatched again inside the processor or inside the running state. Okay, so these are the 5 states of a particular process. Each process has something which is called a PCB. A PCB is a unique ID given to all process. Okay, it's a unique ID, a unique description given to all process. Okay, so each process has a PCB. What are the items inside a PCB? Well, these are the items inside PCB. Okay, what is the current state? What is the counter for the particular program? Because you have to remember, a process is actually a running of a program, and inside this program there are lines of codes. So maybe the process has been executed, but it's only executing up to line number 10, 20, 30. So that is the counter. So that is the counter. So it will indicate this counter, so the operating system knows if this process is now dispatched back again to the processor, it will know from where it needs to begin. Okay, CPU registers. What are the registers involved in that particular process, and what is the scheduling information? Where is this process? Is it in the memory or CPU? And the memory management information. Where in the memory is this particular process located? And how much time is inside the accounting information, and what are the input outputs for that particular process. So each process will have all this inside its PCB. All right, so this is another form whereby a process switches from one process to another. Okay, one process to another process. So each process, when it switches from one process to another process, it's being interrupted. What does interrupt mean? Interrupt means that once a process is running, it will be interrupted. Example here, process 0 is running, but at a certain point of time, it's interrupted here. So when it is interrupted, the process is now sent back to the process 0 is sent back to the memory, and process 1 is now executing. And once it's finished executing, process 0 will continue back from where it left off. Okay, so between a process to a process, the CPU interrupts one process, okay, and continues with the other process. All right. Next, we go into the point of threads. What are threads? Okay, so a thread means the same process. Okay, it's running from the it's a sub process which is running from the same particular process. Okay, so the threads will be different from the process. However, it's an example. Give you an example like this. When you open Microsoft Word, now that is one particular process. When you open document 1, document 2, 3, 4, 5, 6, now that each of these sub-process documents are called a thread. So a thread is a single line under a particular process. If a thread finishes execution, then the process is still in execution. However, if you shut down the process, if the process finishes, then all the threads under the process will be automatically shut down. Okay, so you can imagine like this. Microsoft Word is a process. Document 1, 2, 3, 4, 5, 6 is all the threads. So if we shut down or we close or we exit from thread number 1, the process is still there. However, there is no particular threads running. But if we have another example, if we have thread 1, 2, 3, 4, 5, document 1, 2, 3, 4, 5, and if you close or you shut down the process Microsoft Word itu sendiri, then all the threads under the particular process is now shut down as well. Right. Next, we go into the process scheduling. Okay. So in order for the process to be scheduled, that means now you have to imagine the processes are now inside the memory, waiting to be brought into the processor. Always remember, the CPU can only take in one particular process. At any one given time, there can only be one process. So the remaining process, which needs to enter the CPU, will reside inside your memory, inside your RAM. So inside your RAM, there is a scheduler. So this scheduler, or what we say is a job queue, will queue all the process which needs to be brought inside the CPU. Okay, scheduling queue. All right. But then you might ask, how is it possible when I do my work, I do my work, Microsoft Word, one process, I listen to YouTube, another process. How is it possible? Whereby we can say the CPU can only run one process, but I'm able to listen to two. Well, the answer is very simple, because the CPU runs at a very, very high speed and it has so many buffers. So the sound that you hear from the YouTube comes from a buffer. Okay, it is not coming from the memory. However, if you change song, well, the CPU does that for you, but the time is so fast that it splits or it switches between process very, very fast. Okay, so this ready queue is inside your memory. So inside the ready queue, okay, between the ready queue to CPU, this diagram here, okay, this whole thing here is inside the ready queue. Okay, inside the ready queue. So there is inside the ready queue, there will be a queue, okay, a scheduler which keeps track of all the processes which needs to go into the CPU. Because some process cannot begin until when the input happens. Some process needs some time. Okay, that means it only executes at a certain point of time. Some process, they will break into another process. That's why we have here fork a child. Fork a child means the process is breaking into two sub-process. Okay, an example of a process which is waiting for input output queue is, for example, if you go to the checkout counter in a supermarket, okay, where you check out your items at the cashier, that PC, that counter machine at the counter is actually in a ready mode. The system or the process is waiting for an input to happen. Only then, okay, only then the price can be displayed on the screen. Okay, else the process is now just in the waiting queue. Okay, just waiting for an input to happen, because If the input happens, only then the process can begin its process. Okay. If the process does not get an input from the barcode, then the process will not begin. Next, we also have the time. How long can the process be inside the ready queue? Okay, that is why you see your PC, after a certain period of time, even if your PC is running on YouTube, automatically it switches to a screensaver. Automatically, your screen disappears. So that is whereby the process, the ready queue has a time slice inside the memory. It detects after a certain period of time if there is no more process coming in, if there is no movement from the input output, then it shuts down. Oh, no, sorry, it does not shut down. It goes in the standby mode and the monitor off. Okay, so those are time slice expired. Okay, so inside the scheduler, there are a few types of schedulers, sub-schedulers as well. There is something called the short-term scheduler and the long-term scheduler. And each process is broken down into two types of process. Okay, let's concentrate on this first. Each process inside the ready queue, okay, ready itu dalam memory, okay, there are two types of process. One is what we say as the input-output bound process, and another one is what we say as the CPU bound process. An input-output bound process is whereby the process spends more time doing input-output rather than computation. Example, macam tadi kat supermarket, the process is only doing getting an input from the barcode reader and displaying. So there is very little minimum, or there is very minimal CPU process. It's only receiving inputs from the barcode reader and display. Okay, the display is very, very fast. Okay, so but most of its process are on the input from the barcode reader. So those are examples of input bound process. Another example is when you go into the toll gate, RFID, touch and go. Those are input-output bound process because they are only waiting for an input to happen. Only then the process begins. Okay. All right. A CPU bound process spends more time doing computation and a very short time, a very long CPU bus, and what we say is the opposite of input bound. Okay. CPU bus means that means the processing time inside the CPU. CPU bound process is whereby when you are doing a multimedia, you are doing rendering. You are rendering your movie. Okay, that means you are joining in all your movie sections. So that is what we say is a CPU bound process, because the CPU is working around the clock to finish up the video. Okay, so that's why you need a high speed CPU to work on this, because it's doing a lot of jobs in order to render the movie, to join in the movie, okay, to join in all the music. So that is a lot of CPU work. So you need a good CPU. So that process is known as a CPU bound process. So in both of these processes are inside the ready queue. Okay, inside the dispatch, inside the ready queue. So the operating system needs to choose which process goes in and out of the CPU. If the CPU chooses a CPU bound process, then the process will take a long time. The processor will always be busy. That means it will never execute other processes because it's now focusing only on CPU bound. If the operating system chooses a input-output bound process, then all the computational, all the rendering process, images or whatever will not be processed. Will be processed, but at a later stage. So that's why the operating system needs to select between what we say as the short term. The operating system needs to choose an CPU bound process or a input-output bound process. Okay, so there are two types of scheduler. Okay, there's two types of scheduler. One is called the short-term scheduler and one is called the long-term scheduler. Okay, so the short-term scheduler works as if, okay, works to bring in all the processes at a very short period of time. That means every 1-2 seconds, dia akan bawa proses masuk. And it will bring in any process, either import output or the CPU box. However, the long-term scheduler works differently. The long-term scheduler chooses long or what we say is a long time process. Proses yang panjang. So it will choose that. Okay. So both of these scheduler works side by side dalam memory. So the operating system will choose either a short term or a long term in order to bring in the process which needs to be processed by the CPU. So the long-term scheduler is also to control degree of multi-programming. Multi-programming means your PC. It means it can run multiple programs at one given time. Okay, at one given time. So the CPU scheduler, which is either the long-term scheduler or the short-term scheduler or the long-term scheduler, maintains this degree of multi-programming. That means the number of process being processed in the CPU is the same. That means ada short term, ada long term, ada short term, ada long term. Okay, and is also going to process input output or CPU1 process. Okay, it's replicating between both. Okay, it's changing between both. Sekejap dia akan buat input output, sekejap dia akan buat CPU1 process. Alright, a medium term scheduler pula does swapping. That means, okay, it will remove the process from the memory and execute it. Or remove the process from memory, store on the disk and bring it back from the disk to continue executing. This is what we say as swapping. Okay, swapping ni macam you buat control alternate delete, you end task, you buat proses lain. Okay, this is what we mean as medium term scheduler. A medium term scheduler means, okay, if the process is running at a very long time, then the operating system will stop that particular process and swap it with another process. Okay, dia akan remove the process. Mungkin proses tu dah lama sangat tunggu dalam memory, so dia akan keluarkan and terus masuk dalam bring it back from the disk to continue executing. Okay, why does it need to be stored back in the disk? Because if it's too long waiting, so it will shut down one particular process, letak dalam hard disk, and bring whatever new process back into execution. Okay. A medium-term scheduler is like what I said, is something like swapping, or we do in operating system, we do switching, meaning to say you switch the program. You interrupt the program, you just change the screen. Okay, like now I'm doing PowerPoint, so I can there's a special command where I can switch this process to another particular process. So I take it out and I switch it to another program. All right, multitasking in mobile system. Okay, mobile system also works the same as the the operating system. Okay, the operating system in the mobile system works almost the same, but it has two different kinds of program. One is the foreground, one is the background. Okay, the foreground is what you see on your mobile phone, whatever apps you see on the user interface on the front screen, but the background process is the memory, the time, and all those are what we say as the background process. So again, okay, again in the same concept, kalau foreground and background, so there is a limitation of how much foreground process and how much background process can be used at one single point of time. Because if the Android or if the iOS is focusing more on foreground, then background process takkan jalan. Kalau dia buat background process saja, your foreground process takkan jalan. Okay, it needs to control which program comes in and go out. Okay, so context switch is almost similar like what I said just now. Medium term scheduler. Okay. Now, operations on processors. So in order for the operating system to run a particular process, First, the process must be created, okay, then brought into the memory, then brought into the CPU. Once it's finished, it goes into termination and so on. So for each particular process, it goes through the same process. You create the process, you put it inside your memory, you run the process inside your CPU. Once it's done, you terminate it and store it back inside your your hard disk. So each parent process creates a child. A child process is like what I told you just now, is a fork. Sorry, it's a thread. So parent process, Microsoft Word, child process is document 1. Okay. And then so each process has a process ID. Okay. So this is how the fork system looks like. Okay. These are all the programming codes you need to know. Okay. You need to know lah. Tapi ini kalau you buat programming lah. Okay. Let's see what else do you need to know. Okay, let's do this. 3.4. In order for a process to talk to another process, it will talk using something which is called interprocess communication. Process with a system may be independent or cooperating. Independent means a process run by itself. Cooperating means this process needs to wait for another process for it to complete or for it to share data. Contohnya macam, let's say you are running, okay, let's say let's go back to the supermarket example. Okay, the process, okay, of getting the input from the barcode reader, lepas tu check dengan database, checking dengan database, and the price is displayed. So ada dua proses kat sini. The input datang daripada barcode reader, dapat barcode tu, that barcode will be passed as the input to another process. So the other process dia akan check dengan database berapa harga dia and display on the screen. So how these processes talk to each other is they use something which is called interprocess communication. So they are cooperating between one another. Why do they cooperate within one another? Because they want to share information. They want to speed up computation. They want is much more convenient. That means one process dia akan buat input, habis they can pass to another process. Now this process will do the searching the database and so on and so forth. Okay, so there are two models of interprocess communication. Shared memory, that means both of these process uses the same memory. Sama juga macam Microsoft Word and document 1, 2, 3, 4. All these processes, Microsoft Word, document 1, 2, 3 ialah proses. Cuma document 1, 2, 3 is a process inside a process. But all of these processes share the same memory location. That is why you can copy paste from one document to another document to another document. Okay, because all of them are sharing the same information. Sorry, same memory location. Okay, so this is how it looks like. So between the process, you have a shared location here. Okay, so these two processes are actually the same. This is the main process. This is document 1, but both are sharing the same location here. If you have document 3 or document 2, you have it here, and the shared memory size will increase. That means process ni pun boleh access, process B and C boleh access. In Microsoft Word, they share the same because Microsoft Word ni datang daripada Microsoft Office kan. So all of this, if you open Excel, so Excel also will share the same memory because it all comes from the same process lah orang kata. Okay, because ini daripada Microsoft Office. So that is why you can share, you can copy from Excel sekejap, paste to PowerPoint, paste to Word. Okay, because all of them are having the shared memory. In cooperating processes, there are also some process which is independent. Independent process cannot affect or be affected by the execution of another process. That means it's independent. Contoh proses yang independent. Your virus, sorry, your virus is not virus scanner is not an independent process. Your time, Okay, time is independent because it does not care. You run lah Microsoft Word ke, Excel ke, PowerPoint ke, tapi I will still do my time. Okay, dalam operating system. Or your antivirus, betul lah, antivirus program. It is not worried about any process. Dia akan run continuously. Okay, dia akan run continuously. Your screensaver program, dia akan run continuously. Dia ada time, tapi it's not worried about any other process. Kalau operating process is affected, that means kalau you open Word and you open PowerPoint, they akan affect within one another because it both shares the same, same memory location. Okay, so these are some of the advantages of having operation process, information sharing, speed up, and much more convenient. All right. So other than that, yang lain semua, okay. Okay, this consumer problem ni, okay, you can read it on your own. This is very much easy, nothing much here. And yep, okay. So we are almost at the end of this chapter. Direct communication, buffering. Okay, all right. This is okay. Yang bawah ni you can read it on your own. It's nothing much. Okay, it's all talking about the same process saja. All right. So again, we are a very short class today. We will stop now. You have any questions for me? Nak tanya soalan ke? Okay. So what we have learned so far in this chapter is about process. So you need to understand what is a process first. Tahu definition of a process. Yang keduanya, you need to understand what is a job, what is a batch system, time shared system. All right. This is very important. And you have to understand what are the states of each process. So you have to remember these 5 states. And you have to remember the the items inside a process control block. What is a process control block? You have to know. So what are the items inside a process control block? Selalu ditanya. And you have to also imagine, or you have to also understand, where is each of the state? Di mana location? If you say, let's say a process is in the ready state. So where is it? So it's inside the memory. If a process is inside the running state, where is it? It's inside the CPU. Okay. You have to understand what is a thread. Give me examples of a thread. What is a scheduler? Okay. Scheduler is a program inside the ready queue. Why is a scheduler important? Because it selects which process to be brought into the CPU. And you also have to understand, you have to know what are the types of process. So kita ada input bound process and output bound process. And we have 2 types of scheduler. One is the short term and one is the long term. So kalau short term dia bawa proses-proses yang CPU sahaja. Kalau long term dia akan choose proses yang input output. Okay, long term is very important to maintain degree of multi-programming. That means it has to make sure that each process in the CPU is not taking so much time. So they can maintain. Okay, and a medium-term scheduler, medium-term scheduling sama juga macam context switch, whereby it swaps the old process and puts in a new process. Okay, swaps a new old process and brings in a new process. All right. How does the process talk to among each other? Well, they use something which is called the IPC, which is the inter-process communication. How does the inter-process communication work? They would share memory between processes. Why is the inter-process communication good? Because it shares information, it speeds up, and is much more convenient. Okay? Yang lain ni is nothing much. You can just finish up reading on your own. Okay? All right. Any questions so far?
No, sir.
Okay. All right. So I leave you all again early today.